Hello again, ladies and gents. Hope you had a decent weekend. I know Sunday was a little bit of rain out, but what can you do, right? Okay, so we were adding fractions. First thing we were chatting about was that before you can compare fractions, add them or subtract them, that you have to get a common denominator. So that's what I did with these two here. So we had 6 and 7 as denominators. 7's a prime number, so the only way we're going to get a good common denominator is by multiplying it with the other one. And that's the easiest method anyways. So 6 multiplied by 7 is 42. Okay, and then I forgot to show it with this one, but I can quickly draw it in. So what did we do to 6 to get it to be 42? Well, we multiplied it by 7. So I'm doing the same up here. 7 times 7 is 49. What did I do to 7 to get it to be 42? Well, it was multiplied by 6. So we're multiplying that by 6 and that by 6. Okay, 6 times 5 is 30. Now we can add the numerators. So 49 40-seconds with plus another 30 40-seconds gives us 79 40-seconds. Improper fraction, so we want to put that back into a mixed number in lowest terms. So we want to see how many groups of 42 will fit into that, and it just goes once. And then after we take a group of 42 out of this, we're left with 37 more. Okay, over to D. So we have 13/10 and 4/3 being added together. Again, 3 is a prime number, so the only way I'm going to get a common denominator is by multiplying them together. So this whole fraction was multiplied by 3, and this whole fraction was multiplied by 10. Okay, so that gives us 39 over 30 and 40 over 30. Add the numerators, 79 over 30. How many groups of 30 go into 79? Well, one group of 30 is 30. Two groups of 30 would be 60. Three groups of 30 would be 90. So I'm not getting three groups, so two whole groups, which is 60. Once I take 60 out of this, it's sitting right there. That's 60/30ths right there. I have 19/30ths left over. Okay. The other thing to check is, are these lowest terms? So we want to check, can we divide both numerator and denominator, by the prime numbers? So I could try dividing them both by 2. That wouldn't work because that's not even. Dividing by 3, then 5, then 7, then 11, then 13. If you get up to 13 and both of them are still giving you, or one of them's giving you a decimal number, they're not both coming out as a whole number, then you probably have it in lowest terms. Same with this. 19 is a prime number if you keep going it with them, and 30 is not divisible by 19, so we know we're done. Okay, so 4A gave you an answer of 1/2, 3/4, and 9/10. And it said write the fraction as the sum of two fractions with the same denominator. So sum means answer to an addition question, and they wanted us to add two fractions together to give us that answer. And with the first bit, they said same denominator. So with the denominators, since it with that first one, 1/2. Well, I can't do 1/2 plus 1/2 because that would be a whole. So I needed to make it this smaller, which means break this into more pieces. So I kind of doubled it. So I made an equivalent fraction for 1/2, 2 over 4, and I did that by doing 2 and multiplying it by 2 both times. So that gave me 2 over 4. So that's the same answer. It's just that in equivalent fraction form. It's still worth the same. If you do 1 divided by 2 in a calculator, you get 0.5. If you do 2 divided by 4 in a calculator, you get 0.5. So then in this case, 1/4 plus 1/4 gives me 2/4, which is the same as 1/2. Okay. With 3/4, same thing. Two fractions. We want to get their sum, adding them, or it gives us 3 over 4, and we want the same denominator. Well, since they gave us already quarters, I can do 1/4 plus 2/4 gives me 3/4. So that one's fairly easy. And the same with this one, with it being in tenths. You can choose any two fractions that will add up to 9. So I did 1/10 and 8/10. Okay. Now, part B said they still wanted the sum of two fractions to equal 1/2, 3/4, and 9/10. But this time, they had to have different denominators. So what I did was I actually used these same combinations. So a quarter plus a quarter equals 2 quarters, which we already know is a half. Okay, but I just made one of them an equivalent fraction. So 1 quarter, if I multiply both of these by 2, 1 times 2 is 2, 4 times 2 is 8. So that's still a quarter. It's still worth the same amount. So when I add that to a quarter, I'm going to get a half. And just to prove it, I put them both as fractions over 8. So 2 eighths plus 2 eighths gives me 4 eighths. Drop this in the lowest terms by dividing by 2, and I get a half. Okay. Same idea here. I still took my first solution, and I just made one of them have a different denominator by doing 2 times 2 is 4, 4 times 2 is 8. So 4 eighths instead of it being 2 quarters. Switch this to a fraction over 8, again by multiplying by 2. So 2 eighths plus 4 eighths gives me 6 eighths. Drop that into lowest terms, divide both numerator and denominator by 2. I get 3 quarters, which is what we wanted. And then, same with this one. I'm still doing 1/10 plus 8/10 gives me 9/10, but I've changed this one to a fraction over 20 by multiplying them both by 2. Change this to a fraction over 20. So 2/20 plus 16/20 is 18/20. Divide that by 2, and I'm back to 9/10. Okay, jumping over to 6. They gave us some fractions and whole numbers, fractions and mixed numbers here to work with. So 7 eighths plus 1 2/3. First thing, when you have a mixed number throughout this entire unit, don't deal with it as a mixed number. Please put it as an improper fraction. So we discussed the idea that this whole fraction is broken into thirds. So how many thirds do I need to make a whole? 3 thirds. Like say if you had a pizza chopped into 3 pieces, how many pieces do you need for it to be a whole pizza? 3. So every time I get 3 thirds, that's worth 1 whole. So that's what that is there. That's saying I have 3 thirds sitting here already, plus an extra 2 thirds sitting around. So when I put that all together, how many thirds do I get? 5 thirds. Here's the shortcut, okay? Do 1 multiplied by 3 is 3, plus 2 is 5. Okay, so 3 times 1 is 3, plus 2, 5. Now that I have my mixed number as an improper fraction, now we'll find common denominators. Again, 3 is a prime number, so I'm just going to multiply the 2 denominators together. So this whole fraction gets multiplied by 3, and this whole fraction gets multiplied by 8. Sometimes 3 is 21, 5 times 8 is 40. Add 21 24ths and 40 24ths together, I get 61 24ths. How many groups of 24 fit in there? Well, 2 groups of 24 is going to be 48. Multiply those both by 2. So then I will take 48 out of that. There's my 48 24ths sitting right there. How many are left over? 13 of them. And I just, to get the 13, 61 subtract 48. I just didn't show it. Okay. So over to E, same thing. I've got a mixed number. Let's make it an improper fraction. 5 times 2 is 10, plus 3 is 13. So I have 13 fifteenths and 2/3. These are both prime numbers, so for sure we're multiplying together. So this whole thing gets multiplied by 3, this gets multiplied by 5. And again, those numbers are coming from the other denominator. Gives us 39 fifteenths and 10 fifteenths. Add the numerators together, I get 49 fifteenths. Now, back into a mixed number. How many groups of 15 can I get in there? Well, we know for sure one group will fit in. 2 groups of 15 is going to be 30. 3 groups of 15 will be 45. And then that's pretty close. So that's all I'm getting in there. So there's 3 groups of 15 sitting right there. That's worth 45. After I've taken the 45 out, 4 left over. And sorry, again, we should be checking are these in lowest terms. So looking at that fraction, 13 is a prime number. So the only thing I'm going to be able to divide by is 13. And if I try to do 24 divided by 13, I will get a decimal answer. So that's lowest terms. Over here, looking at it, neither's a prime number. So we're just going to start with the prime number. So again, 2, 3, 5, 7, 11, 13. So I'll try dividing them both by 2. Okay, it'll work for 4. I'll get a decimal answer for 15. So then try 3. 4 divided by 3. I get a decimal answer, so I know that's going to work. And I'm already over top of my numerator. 5's larger, so it's not going to work. So that tells me that's lowest terms. So on to F. Two mixed numbers. So here we go. 5 times 5 is 25 plus 2, 27. 1 times 8 is, oh man, I knew this one. Hold on. Wait. 8. That's right. Plus another 7 is 15. Multiply the denominators together. That's what I'm doing here. This whole fraction times 8, this whole fraction times 5 gives me our common denominators. So 216 over 40 and 75 over 40. Add the numerators, 291 over 40. And then how many groups of 40 fit in there? You can use your calculator. You could just do 291 divided by 40 to see what the whole number is. But we can do this mental math, okay? Forget 40. Let's just deal with 4. 2 times 4 is 8. So in this case, 80. I can go more than that. 3 times 4 is 12 or 120. No. 4 times 4 is 16 or 160. If you put the 0 back on, I can do more than that. 6 times 4 is 24 or 240. 7 times 4 is 28. Oh, so that would be 280. So yeah, that's really close. So take my 280 out as the 7 whole groups of 40, and then 280 or 291 subtract the 280, 11 left over. Okay, so that's where that came from. And then again, you always check, is it lowest terms? Well, hey, look at that. They gave us another prime number as a numerator. So the only way I'm going to get this to go lower is if 40 is divisible by 11 for a whole number answer, and it's not. So we don't have to reduce. Okay, so number 7 said 2 students, Galen and May, worked on a project. Galen worked for 3 2/3 hours. May worked for 2 4/5 hours. What was the total time working on their project? So there's Galen's time and May's time. You can see I'm changing them to improper fractions. 3 times 3 is 9, plus another 2 is 11. 2 times 5 is 10, plus another 4 is 14. Looking for common denominators now, I'm just multiplying them together. So this whole fraction by 5, this whole fraction by 3. Gives us 55 over 15 and 42 over 15. Add the numerators, 97 over 15. And then just how many groups of 15 can you get in 97? We get 6 whole groups. Once we take those out, there's 7 left over. And again, we're checking, is this lowest terms? Well, hey, they gave us another prime number as a numerator. So I'm going to check, is 15 divisible by 7? No, I get a decimal answer. So that is lowest terms. And then finally 8. They're giving us 3 fractions to add together. They've given us an improper fraction here and then 2 proper fractions, so I don't need to switch anything. We're just looking for common denominators. I have 4, 5, and 6. I'm just going to multiply all 3 together. We could check. 4 times 5 is 20. 20 is not a multiple of 6. I could do 6 times 5 for 30. 4 is not a multiple, or 30 is not a multiple of 4. And I can do 6 times 4 for 24. That's not a multiple of 5. So I'm just going to multiply all 3 of them together. 4 times 5 times 6 is 120. That's my common denominator. So then this whole fraction, 5/4, needs to be multiplied by 5 and by 6, by the other 2 denominators. So that's what I did here. So 5 times 6 gives me 150. This fraction, what did I do to 5 to get it to be 120? Well, I multiplied by the 4 and the 6. And then I did the same to the numerator. 3 times 4 times 6, 72. What did I do to 6 to be 120? I multiplied by the other 2 denominators. So it got multiplied by 4 and by 5, and then same as the numerator. Now, add all 3 numerators together, I get 242 over 120. How many groups of 120? Well, 2 groups of 12 would be 24. So 2 groups of 120 would be 240, which is really close. So I know I can get 2 whole groups of 120 out here, and when I take that out, I get 2 left over. Now I'm looking at this. Is this lowest terms? Well, no, we can divide by the prime numbers. So I'm going to divide by 2 and divide by 2, and I get 1 over 60. I know that's not going any lower, so that's done. For E, again, 2 improper fractions, 1 proper fraction, and I'm looking for a common denominator. So you can instantly just multiply all three denominators together. It'll just mean you have more reducing at the end. That's okay. If you can make it smaller, sometimes it makes your life a little bit easier. So I did check first, if I just do 10 times 5, what does that give me? And it's 50. I know 50 is a multiple of 2, so I'm going to go with that. Okay. So what did I have to do to 10 to make it 50? Well, multiply by 5. So 7 times 5, 35. What did I do to 5? It got multiplied by 10. So my numerator did as well. Over here, what I have to do to 2 to make it 50? Oh, multiply by 25. So 7 times 25 is 175. Add the numerators together. How many groups of 50 go on there? Well, 5 times 5 is 25, so 5 times 50 is 250. I'm not going to get 300 out of there. So I get 5 whole groups. When I take my 250 out, there's 30 left over, and I'm left with 5 and 30/50ths. Then check. Can I bring this down? Well, they both end in 0, so I know they're both multiples of 10, so let's divide by 10. Gives me 3 over 5. These are both prime numbers. I'm done, okay? When you do reduce, remember, bring down your whole number too, okay? I've seen students just show the fraction and leave the whole number. That is completely wrong. Okay, so on to this one. Again, hunting for common denominators. First, I checked 12 times 5, which would be 60. And then I tried to see, is 4 or is 60 a multiple of 4? I was unsure. So I went on my calculator and I tried 60 divided by 4, and it told me 15. So, oh, okay, cool. I know 60 is a multiple of 4, so I can use that as my common denominator. And then before I forgot, I wrote down multiplied by 15 here, and then I did the same to the numerator. To get 5 to be 60, I multiplied by 12. So I did the same there, gave me 72. 12 was multiplied by 5, so 5 times 5 is 25. Add the 3 numerators. How many groups of 60 go into that? 2 of them. There's 22 left over. Check, is this lowest terms? Well, let me try dividing by my prime numbers. I started with 2, and I got 11 over 30. Then you got to check, can it go lower? Oftentimes it will. 11's a prime number. The only thing I'm going to be able to divide by is 11. Can I do that with 30? No, I get a decimal answer. So that's it for that one. Okay. Yeah, no horrible dad jokes. Maybe I'll get one in the next lesson. No promises. All right, take care. Bye for now.